Okay. Good afternoon, everybody. So we were discussing about beats, and you will receive the assignment today about beat tracking. We discussed about the notation which we use. Yeah, in the previous class, we discussed about beat estimation, that how when we have beats, then they are arranged in a particular structure so that it's musical. And then we also discussed about the notation or the representation, the musical notation that we use to represent beats, like dha, dhin, dhin, na, so like that. And then we discussed can we detect these beats automatically from audio signals, and for that we saw that audio is there, and the audio looks something like this, where you have some peaks coming, but then those peaks could be a little bit off, right? Means if I only go with the max peak may not be the onset time, right? And we are interested in the onset time, when actually it is causally connected with when I hit the drum or whatever instrument I'm using. So we saw energy as a very good possible measure to detect the onset, right? Because whenever the onset will happen, the energy will increase. What is energy? Energy is kind of, you take the amplitude values in a short neighborhood, in a short window, square them up, and then add them up. That is the energy, right? So this you are seeing here. This is the energy. You take a xn plus m, means the shifted version of xn. Look at a short neighborhood wn, multiply with wn means that small window, everything else becomes zero, only that window is present or highlighted, and then you square every entry and then sum them up. That is the energy in that window. And this energy alone may not be sufficient to tell the onset, but the rise in energy, how the energy is increasing suddenly. Like if you see the energy suddenly starts rising, then that slope tells you onset has occurred, right? So now, when you are looking at these equations, don't assume these equations as sacrosanct, right? What is sacrosanct is the observations which we are making. Let's say in music we observe that there is a beat structure, and now we have to design these equations to somehow estimate those things in the audio, right? So it's very different from what we have been seeing in the past, that equations are sacrosanct and everything else is an outcome of equations. Here, things are sacrosanct, or what we are studying, the phenomena, that is kind of observations are sacrosanct, and these equations are trying to estimate or capture those real observations. Okay, so just like we have in the waveform, these methods, like you estimate the energy, look at the energy difference. It's called the energy-based novelty function. Novelty tells that something new has happened, so energy has risen suddenly. But similarly, we can also look at the spectral domain. Do you know how does the spectrum look like? Okay, so our spectrogram looks like. Let me quickly go to Pratt and show you how spectrogram will look like. New sound. I need something to make sound. Maybe I will use this stick. Right? This is a kind of beat-like sound. I say record.